Okay, so we have this question here. Let's z is 5 over 2 plus I minus 1. So we're going to say what z is. That's going to be 5 over 2 plus I minus 1 times 2 plus I all over 2 plus I. Now we have the same denominator, which is all going to be 2 plus I. Next we're going to have 5 minus 2 minus I, which is going to be 3 minus I. There we got to do top and bottom is 2 minus I and 2 minus I. Okay, and then it's going to be multiply these in, and what we're going to get is 6 minus 3i minus 2i. Then it's going to be minus I squared, which is plus I squared. And then it's going to be 2 plus I, 2 minus I. So 2 multiplied by 2 is 4. 2 multiplied by minus I is minus 2i. I times 2 is plus 2i. And then I times minus I is minus I squared. Then what we're going to have on top is we're going to have I squared changes into minus 1. So 6 minus 1 is 5. It's going to be 5 minus 5i. The 2 i's cancel the bottom. Minus I squared is plus 1. It's going to be all over 5. And that's going to be 1 minus I. So that's going to be 1 minus I is in the form a plus b. Now it wants me to evaluate. Z is 1 minus I. What it wants me to do next is it wants me to evaluate z to the power 6. So I have to change 1 minus I z into polar form first. So it's going to be 1 to the right and 1 down, which is going to be around here. Draw the thing. And then we have 1 and 1, and my job is to figure out what is the angle here. Okay, and that angle is going to be the angle x. Okay, so tan x is 1 over 1. X therefore is tan inverse 1. X is 45. This is the angle 45 degrees. Take it away from 360. 360 minus my 45 gets me my 315. Okay, next thing I have to figure out is what's the r value. The r value is the square root of 1 squared plus minus 1 squared. It's basically the length of the hypotenuse using the modulus formula, which is going to get me root 2. So r equals root 2 and theta equals 315. Okay guys, and then we're going to have n equals 6. So we're going to use, first going to write it in polar form. Polar form is root 2 multiplied by cos 315 plus I sine 315. Now we're going to have to do the whole thing by z to the power 6. So put the power 6 on the outside. Now it's going to be root 2 to the power 6. And 6 multiplied by 315 is 1890. So it's going to be cos 1890 plus I sine 1890. Once we put this in again, what we're going to get here is root 2 multiplied by root 2 to the power 6 is 8. And then we're going to have, so it's going to be, just check that out, root 2. Then the answer to the power 6 is 8. Cos 1890 is 0. So 8 times 0 plus, now sine 1890 is going to be 1. So we're going to get a 0 plus 8i for question 20. Okay, so question 20 is just going to be 8i, which we have there. So 22. Express a plus ib in the form r cos theta plus I sin theta, and hence or otherwise calculate a plus ib to the power of 11. Okay, so we have the second one is question 22. So what we're going to do is going to multiply this out, and we're going to get is 2a plus 2bi. Then we're going to get 3ai plus 3bi squared. And that all equals minus 1 plus 5i. Now what you can see here is we have a real. Now this one's going to be real in a second because the I squared is minus 1, so it's going to be minus 3b. So that's also real. And that's real. So we have 2a minus 3b equals minus 1. That's the real equation. The imaginary equation is 3a plus 2b, and that equals 5. So we have a real and an imaginary equation. We're going to set up these. They're linear, simultaneous. So multiply the top by 2, the bottom by 3. And what we're going to get is 4a minus 6b equals minus 2. We're going to get 9a plus 6b equals 15. Then we're going to cancel. And we're going to get 13a equals 15 minus 2, which is 13. A equals 1. Now we know that a equals 1. We substitute it back in here. So we're going to get 2 times 1 minus 3b equals minus 1. 2 minus 3b equals minus 1. Bring over the 2. Minus 3b equals minus 1 minus 2. Minus 3b equals minus 3. Divided by minus 3. Minus 3 divided by minus 3. b equals 1. So it's actually going to be 1 plus I for question 22. Okay, so it's 1 plus I. So far what we've determined is that this number a plus bi is, this part here, is 1 plus 1i, because a equals 1 and b equals 1. Now we have to change it into polar form. So what we've got to do is we've got to draw our axis. And once we draw our axis, we know that it's 1 across, 1 down. So what we're going to get here is that's 1 and that's 1. Figure out what the angle theta is. Tan theta equals 1 over 1. Theta equals tan inverse 1. Tan inverse 1 is 45 degrees. So theta equals 45 degrees. Okay. Next thing is the r value. Well, r is going to equal the square root of the coefficient, the real value plus the imaginary value squared. So r equals root 2. So in polar form, what we're going to get in this form here is going to be root 2 cos 45 plus I sine 45. And that's us done there. Now that that's done, what we're going to do next is we want to do this value to the power of 11. So you want to root 2 by cos 45 plus I sine 45. And all of that is to be the power of 11. So this is where we're looking at probably using the Myers theorem here. So we have to select our r, our theta value, and our n value being 11. So what we're going to get is 11 times 45 is going to be 495. So 495. So it's going to be root 2 to the power of n, which is power of 11, plus cos 11 theta, which is going to be 11 times 45, which is 495, plus I sine 495. And now we're going to have to multiply a root 2 to the power of 11. So root 2 equals root 2, answer to the power of 11. And you only get let's do root 2 to the power of 10 first. Okay, interesting. Root 2 to the power of 11. Now to give us this number here, so let's try root 2 to the power of 10. We get 32. So it's actually going to be 32 root 2. Because it's the same thing. Root 2 to the power of 11, same thing as root 2 to the power of 10 by root 2, which is 32 root 2. And then cos 495. Cos 495 is going to be minus root 2 over 2 plus I sine 495 is root 2 over 2. So plus I plus root 2 over 2 times okay. So what we get here is our answer. Oh sorry, we'll just do it this way. 32 root 2 multiply by fraction button here, we're talking about minus root 2 all over 2. Then what we get here is minus 32. So it's going to be minus 32 plus 32i. Okay, so it's going to be minus 32 plus 32i for question 22. Now we're on question 25. Now, question 25 said 1 is cos pi over 3 plus I sine pi over 3. Said 2 is cos 4 pi over 3 by I sine 4 pi over 3. Express said 1 squared. So that's said 1 squared. So let's find out what said 1 squared is. Said 1 squared is cos pi over 3 plus I sine pi over 3 all to the power of 2. Once again, you're using the cosine rule. Okay, so n equals 2, r equals 1, theta equals pi over 3. So what we're going to get when we do this, it's going to be n times theta, which is 2 pi over 3, so it's going to be cos 2 pi over 3 plus I sine 2 pi over 3. So cos 2 pi over 3. And once again it's in degree mode, so I have to change the setup to bring it back to radians. So it's going to be cos 2 pi over 3. And we get there is minus a half. Okay, so we're going to get minus a half plus I sine 2 pi over 3. So we're going to go for sine 2 pi over 3. Which is root 3 over 2. I. So that's what we have. Next one is going to be said 2 to the power 4. So I have to figure out what said 2 to the power 4 is. And said 2 is cos 4 pi over 3 plus I sine 4 pi over 3, and it's going to be to the power 4. So this time we're going to get cos 16 pi over 3 plus I sine 16 pi over 3. So I have to figure out what cos 16 pi over 3 is. So cos 16 pi all over 3. And what we figured that out to be is minus a half. And then it's going to be plus I sine 16 pi over 3. So once again figure out what sine 16 pi over 3 is. And what we get there is minus root 3 over 2. I. Okay. So there we go. That's set 2. Now, the problem with this is it wants me to figure out what are the two answers multiplied by each other. So what is A multiplied by B? Okay, in the form A plus BI. So, what I could have done, I already have them in this form here, so what I can say is this is going to be a half minus a half plus root 3 over 2i minus a half minus root 3 over 2i. It's going to multiply them out now. I'm going to get plus a quarter minus root 3 over 4 times I minus, that's plus root 3 over 4 times I minus root 3 over 4 times I minus 3 over 4 I squared. They cancel. Minus 3 over 4 times minus 1 plus 3 over 4 plus 1 over 4 equals 1. So all equals 1. Okay? So the full answer is going to be equals 1 plus 0I. And that's the answer for number 25. Yep. Now moving on to number 28. And number 28 is a mixture of the Myers theorem and the compound angle rule, which I'll find for you now. Okay, so with this one here, what we have is cos pi over 3 plus I sine pi over 3 to the power 2. So I'm going to multiply both angles by 2 to use the using the Myers theorem, which is the first one we're going to use. So we're going to get cos 2 pi over 3 plus I sine 2 pi over 3. Then we're going to have to end up multiplying that by cos pi over 6 plus I sine pi over 6. Now this is a multiplication, and what we can see from multiplication is that we generally add the angles together. So A equals 2 pi over 3, B equals pi over 6. So 2/3 plus 2 pi over 3 plus pi over 6 pi over 6, and what we're going to get here is 5 pi over 6. Okay, so A plus B equals 5 pi over 6. R1 equals 1, because there's also 1 outside that and 1 outside that, so R2 equals 1. So we're going to use R1 multiplied by R2 is 1 multiplied by 1, which is grand. And then we're going to get cos A plus B, so it's going to be cos 5 pi over 6 plus I sine 5 pi over 6. Now it doesn't want it in polar form, it wants it in the form P plus QI, so we'll just have to put that into the calculator. Cos 5 pi over 6 5 pi over 6 is minus root 3 over 2. So minus root 3 over 2 plus sine 5 pi over 6 we get a half plus a half I. Okay, so minus root 3 over 2 plus a half I for question 28, part 1. Now, question 28, part 2. Very similar. We're going to use the Myers rule to fix the start. So the Myers rule is going to be multiplying 8 by 2 pi over 5. So we're going to get cos 16 pi over 5 plus I sine 16 pi over 5. Close the brackets. And then underneath that we should get a cos 9 pi over 5 plus I sine 9 pi over 5. Now once again, R1 and R2 are both 1. Angle A is 16 pi over 5. Angle B is 9 pi over 5. And then finally, A minus B is going to be 16 pi over 5 minus 9 pi over 5, which is 7 pi over 5. Okay, so what we get is cos 7 pi over 5 plus I, it's going to be cos A minus B, so it's 1 over 1, which is still 1, and then it's going to be cos 7 pi over 5, and then plus I sine 7 pi over 5. Okay. And then we're looking at the two of these. Once again, we're just going to go to the calculator and cos 7 pi and you can see that this isn't in the usual form, so we're just going to look out for a quick mistake. Okay, so there's a little trick in here, okay? So the trick here is that the fact that what we didn't find out on this one is the minus value. Okay, so what we actually had here was minus, so there's something a bit different about this one, okay? So it's actually it's 9 pi over 5 minus I sine 9 pi over 5. So what we didn't actually have the correct setup to use that formula. So what we're stuck with here now is if we just rub this away here, what we're actually stuck with is this here. Okay, so the trick is not to panic when this happens and just try and think your way out of it. So what we get here is this here, 9 cos 16 pi over 5. Now what I'm going to use is going to try and use a conjugate here to see if I can fix this. So I'm going to multiply top and bottom by cos the conjugate of the bottom. So I'm going to try cos 9 pi over 5 plus I sine 16 pi over 5, or sorry, 9 pi over 5 again. And then on the bottom, what I'm going to have is